Welcome to Yantra Technologies. In this present video, we are going to learn how to make serial communication using this 8051 trainer board. So this 8051 trainer board comes with an Arduino acting as a serial chip in addition to a programmer, a built-in programmer. So you can see already we have connected and we are getting the power. Now I am using another cable. Of course I am using another, but it's not necessary. Once after programming you can remove it and put it here also, but I want to show it simultaneously, so I am using another cable here. So I am plugging it here. So already my COM port was COM5 in the earlier one. Let me show you that. So I am disconnecting it here. When I press disconnect, so it is going to show me COM5 as well as COM11. So please make sure that you keep it in COM5 only. Your COM5 is the programmer port. Let's keep it like this. And your COM11, of course in my case COM11, it need not be COM11 in your case, is the one used for serial communication. So let me remove this LCD as I have done it in the previous program. I am intentionally keeping it here. So I am going to remove the LCD program. It asks me whether you want to remove. Yes. And then this is there, but it is not there. I mean, it's not added to the group. Let me close it and let me double click here. It asks me which program. So as usual, I'll open and I'll choose assembly files. So in the assembly file, I have another program called serial communication. Close. So it got added here. See, when I open this here, you can see here, this program starts with the TMOD. TMOD register. If you want to make serial communication, you have to initialize some registers. TMOD has to be set for 20H, hexadecimal 20. This will give you timer 1 in mode 2. And you have to preload this timer high bit TH1 with -3. -3 means it is 252, because 255 is the one. Of course, -3 means it refers to 252. So I am loading the value with 252. So it gives me a baud rate of 9600. So we are doing the serial communication at 9600 baud, and similarly we have to load the SCON, serial communication control register, with 50H. So it tells the controller that I have to send 8 bits with 1 stop bit and receive enable. So I am using the receive enable bit also. So SETB TR1, this will go the timer 1 on, and I am using move R0 as R7, 30H. This is just a value which I am loading there. And as usual, first I start with DPTR label 1. So here I have created data pointers label 1, label 2, etc., which I have shown in the previous video with LCD. So we are going to have different labels at the bottom. A defined byte is there. So it is DB hello. This is UART communication. As usual, I am keeping the end parameter as 255 only. My label 1 says welcome to BONAM VENKATA CHALAMAYYA Engineering College, comma 255. This string ends here. And label 2, I am 8051 ... You are listening to me at 9600 baud rate. Once again 255. So these 3 strings I have tried to transmit. That's why I have written just this 3. Of course, you can change it. And let's come to this. So first of all, I have loaded the label 1 and ACALL SENDSTRING. This SENDSTRING is a subroutine which is going to just take the byte by byte. So we are going to have this string, I mean label 1, the so-called BVC Engineering College, the title is there, and then I am going to send that. After that, ACALL NEWLINE. So after I send a particular string, whenever I hit enter button on the keyboard, whenever I press enter, it is going to cause me a new line. So similar thing is going to happen here. It is going to print these serial communication messages in a new line. So ACALL NEWLINE, the characters like D and A, hexadecimal D and A if you send, or 10 you send, it is going to give you new line and carriage return. Those two things will be sent here. I will show you the subroutines one by one. Another thing, DPTR label, this is label 1 and this is another label SENDSTRING, and another one once again DPTR label 2, add ACALL SENDSTRING, and then ACALL print int. I am going to print the integers from 0 to 9 just to show you that it is incrementing 0 times first sentence, 1 times first sentence, like that. It is going to give 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and then back to 0, and then it is going to jump back to empty. So this is the main loop. So main loop has some specific subroutines. So these subroutines I'll explain one by one. Basically DPTR label is there, send string, new line, send string, and then send string, like that, and then print integer. So these are basically 2-3 subroutines which are running, and we'll go in detail. First of all, ACALL send string. What is send string? We'll see send string. This send string is going to clear the accumulator A, and as usual it is going to clear A because only to load the code memory byte through MOVC instruction, MOVC A, comma @DPTR. So this is going to load the byte into A, and then if at all it is not equivalent to 255, it is going to send transmission. Otherwise it is going to return. So if at all I have come to end point, I'll return. I don't want to continue the serial communication. But still, if it is in the middle of the string, it continues transmitting. So once you transmit the byte, then you increment the DPTR and SJMP send string. So once again you come to here, you clear the accumulator, increment the DPTR means you are going to the next character in the string. We have defined DB, na? So let me explain you. First of all, it starts with H, sends the H, and then it starts with E, because DPTR increment means H will come to E position. I mean the position of H has now been incremented to E's position, and once again if I increment it, it comes to L, another increment, another L, like that. It is going to increment the location of this label. So it is going to increment continuously, and finally it is going to send that particular byte through this communication. So this send string, just a minute, yeah, send string is going to send this particular string until it completes, and whenever it becomes 255, the end character, it is going to just jump out, it returns back. So this is the send string subroutine. Over. Now another thing, after send string we have got another one, print int. Let us see print int, how it prints. And in send string also we didn't discuss what is ACALL trans. Let me explain trans also. This is the way you send bytes using serial communication. First of all, there is a register called SBUF, serial buffer. So serial buffer register, you have to load it with something. So here my accumulator A is getting the byte through DPTR data pointer. We are getting the accumulator with the required byte. Let us say hello. First H is there, so H will come into A, H ASCII equivalent will come into A, and then it is loaded into the SBUF. And then jump if no bit TI, comma dollar, means it is going to rotate forever there. So it just checks whether TI is a flag, whether there is TI or not. If the TI is there, I mean if the bit is set, then it jumps out. Otherwise if it is low, then it keeps on rotating, jump if no bit. So the bit is not set means it is going to rotate here only. Once if TI is set, means transmission of this so-called S buffer. So whenever this S buffer is sending something, this TI bit will be low. And once if it is set, I mean let's say A is sending something like character H. So after the H is sent completely, this TI flag is set. Then it makes sure that your byte has been transmitted. Then what you have to do, you have to clear the flag. So it has to be cleared in hardware, not in software. So we have cleared it and then returned back. So whenever you are loading the S buffer with some register, after loading it, you just wait for the flag. Whenever the TI flag is set, transmission is over. Next you load it with another byte, like that you continue. So this is trans. And as usual, delay is some delay with some registers. And coming to new line, I forgot to mention in the beginning. So whenever you load with 0D and 0A, so if at all hexadecimal 0D and 0A are sent one by one, it is equivalent to \n. \n in C is the new line and carriage return. So this is the same thing which we are doing in ASCII mode. So this is about new line. And send string is also over. Let's come to the last one, which is the print int. So what is print int? So I'm actually interested in printing numbers from 0 to 9. But the problem here in 8051 is, if I want to print 0, it doesn't print, because 0 is not at all 0. 0 means ASCII 0 is not the real number 0. So hexadecimal 30, hexadecimal 30, not decimal 30, is actually equivalent to 0, character 0. So whenever I give hexadecimal 30, then it gets printed as 0, 31 printed as 1, 32 printed as 2, and so on. After that you will have capital A, small a, etc, etc, all these characters printed. So my interest is from 30 to 3A. Of course not 3A, it's up to 39 only, 0 to 9. So that's why I'm comparing whether the A. See, earlier I have loaded a register with 30H. I didn't mention why it is 30H, because I want to print the numbers from 0 to 9. So to do that, I have taken an arbitrary register R7 RAM register, and there I have loaded it with initially 30H. Now you see in PRINTINT what's happening. In PRINTINT function, first of all A is loaded with R7. Now it is 30H, and it is now checking compare and jump whether it is 3AH, whether it has reached to 9 plus something. After 9 you don't get 10, you will get a semicolon, less than, greater than, all these characters will be printed. So I am just checking whether I have reached to a letter after 9 or not. So if it has not reached, then it will come to TT, that is ACALL trans. So it is going to send first 0. So it is going to, 0 means 30H, which is equivalent to 0. So that gets printed, and then it gets incremented. So it comes to 31H. ACALL new line. So every time I am printing a new line, I am calling a small delay, and then it is returning back. So initially it prints 0, next prints 1, 2, 3, 4, and after that, ultimately after reaching 9, it stops. And see what I have done here. After I reach this 3AH, if at all this is equivalent, it will come to here, move R7 comma 2FH. So before 30H it is 2FH. So anyway it is going to get incremented. So R7 is going to be incremented by this inc R7. So instead of taking 30, I have taken 2F. So I have reinitialized the register R7. So even after reaching from 0 to 9, it comes once again back to 0, 0 to 9, 0 to 9, 0 to 9, like that it is going to implement forever. So this is the way we have written the program. Now let us upload this. Let us compile this, rebuild. If at all this is okay, it doesn't throw any warnings. I have already tested it. So it's showing 0 errors. Now as usual, we'll come to the programmer. Now I'll open the hex. So my PRJ1 only. So it is the serial communication code for the entire strings. And now I'll hit upload. So it has to reach up to E something, E0 to E9 or something. It's done, finished writing. See, we will not see anything on the LCD. We don't see anything happening over there. So the specialty of this particular board is you have a serial communication listening device. Now what you will do is you just open Arduino IDE. So click on Arduino, don't do anything, just open the IDE, and of course we know that this COM port is COM11. So we'll just listen what's happening in COM11, and of course we'll see whatever strings that we are sending appearing over there. You don't have to upload any code, just you make sure that you have the tools, the Arduino Nano, and then it's not COM5, it is COM11. Select COM11 and see what is coming over there, and also make sure that your baud rate is 9600. See, a series of characters are coming. It means the 8051 is just dumping the data like anything. So I'll halt this by pressing auto scroll, and we'll see what it is sending. Please pay attention here. This is the starting one. We have missed something. So welcome to BONAM VENKATA CHALAMAYYA Engineering College. And then hello, this is UART communication. I am 8051. You are listening to me at 9600 baud. This is first thing. And it's not yet over. See, there is a cursor. If I just move further, you see some more things printed. See, after that it is printing 3. See, the moment when I started opening this Arduino, it was 3, and then 4, 5, 6, 7, 8, 9. You can see it is printing, and it is printing now also. Let me scroll it. So 0, 9, 9. After that, you see this is the character semicolon. After that, once again I'm getting 0, 1, 2, 3, 4. This semicolon is probably the 29H, 2FH. So the ASCII value for 2FH is probably the semicolon, and once again 0, 1, 2, 3, 4, 9, 0, 1, 2, 3, 4, 9. See, same thing is printing. This is UART communication. And if you have any doubt whether this is really coming from this or not, I'll show you. See, it's live data. Even if I click the clear output, it is now dumping it freshly. And also I'll show you by, just a minute, I'll reset this button. See, there is a reset button here. When I press this reset button, the controller gets frozen, and simultaneously I'll clear the output. See, I have cleared it. So nothing is coming. See, my hand is pressed. Now I'll release it. The moment itself it is going to dump the data. You can see you're getting the data coming. So this is only to show you that these data are not coming from Arduino, but this is the data coming from the 8051. So we are using the Arduino chip only to display. Generally you can use a hyper terminal also. If you have putty or hyper terminal, even on that also you can see. Let me show you that also. I am closing this Arduino, and instead of using Arduino I'll use a putty. Don't get confused that it is coming through Arduino. It's actually coming through putty or any hyper terminal. Just be online. I have this putty software. So in this putty hyper terminal, you can see I am using serial. So the COM is actually COM 11, and yeah, that's all. I am opening 9600 baud rate. I'll just open. You can see this is the data coming over there. So it's not the Arduino which is sending the data, but it is the 8051 which is sending the data. And once again, by holding this button, I can freeze it. See, it got frozen. Once if I release it, see, it's still dumping. Pause, sending, pause, sending. So this is the way you can do the serial communication. Thank you.